So today we're in section 4.1, graphing linear equations with tables. All right, so in chapter 4, we have actually 7 sections in chapter 4. I know it seems like forever away. It's actually not that far away. Thanksgiving break.
I can't wait.
Can I get an amen?
Yes.
Yes.
Amen.
And we are still going to be 7 sections, okay? Essentially 7 lessons. We are still going to be in chapter 4 of Thanksgiving, okay? So it's going to be a long time. It's going to be about a month in chapter 4. All right, so in 4.1, okay, we're looking at linear equations, and we're going to graph them using tables. In chapter 4, we are going to actually graph linear equations a couple different ways. The first way we're going to learn is using a table, and I'll tell you the significance of it, like why this matters, and it's actually what the line on the graph is showing us. When we get to the end of chapter 4, it's definitely not the most important way to graph, okay? Actually, there's a much quicker way. When I teach you the faster way, you're going to look back to 4.1 and think, man, I wish we had done it that way from the beginning. But there is significance here, and I'll show you why it's important to do it this way. So a couple things you need to know. A linear equation is an equation whose graph is a line. It's a line. All right, so on this test next Wednesday, when you're graphing these, if you graph it, guys, and it doesn't form a straight line, you did something wrong. That's a very easy way that you could check to see if your answer is correct. Any point, and this is what I'm going to show you when we graph our first one, any point, not just the ones that you plotted, but any point on that line is a solution to the linear equation. Slope-intercept form. Y equals mx plus b. You've actually been doing this since chapter 1. You just didn't know what it was called. It's called slope-intercept form, but it also has a nickname. It's also called function form. You're going to see it both ways. All right? Does anybody in here have a nickname? Anybody have a nickname? Anybody hate your nickname? Okay, yeah. Usually we hate our nicknames, and that's why I don't like nicknames, and I just say, whatever your name is, that's what I'm going to call you, unless I'm really sure, okay? But we have nicknames for this formula, okay? The y equals mx plus b. Do you guys remember doing this in chapter 1? 3y plus 3x equals 12.
Sadly.
Okay, he said sadly. All right, to solve for y. And what you didn't realize was when you were solving for y, you were taking an equation that was not in function form, and you were putting it in function form. I just didn't call it that. So what I want to do now is I want to review that. I want you to solve for y here. This was actually on your last test also. Micah, step 1. Subtract 3x to both sides. Guys, we are focusing on isolating the y. That means to first move what's not connected, to subtract 3x to the other side. So now 3y equals, Avery, which term would I write first, the negative 3x or the 12? Very good. The negative 3x plus 12. Okay, and then I have one more step. Allie, what's my last step?
We have to divide 3
Yep.
on both sides.
Very good. Divide everything by 3. And I get y equals negative 1x plus 4. So what we've done in the past to solve for y, yes, we've done it in this order. And now we're calling it something. We're calling it function form. You see that y is solved for. Your m, which is negative 1, you're going to learn tomorrow what that number means on a linear equation, on a graph. That number is significant. And then you have your x, and then you have your b. Your b is your number by itself, and this is very significant. I'm going to teach you in, I believe it's section 4.4, how to actually use this number to graph a linear equation. Okay, so we have it in function form. I want you to learn what this is called, okay? Because we've been doing this all year, but we've never called it function form. So now we're going to look at a linear equation on a table, okay? So you're not going to see this table. I'm actually going to show you a different way that you can write it on your homework. But the first thing I need you to understand is how I'm coming up with my x and y values. Okay, let's read the statement. You make up. What does it mean to make something up?
It's fake.
Okay, well, it's not necessarily fake, but you came up with it, right? You came up with it if you made something up. So a table of values. You could choose any set of numbers you wanted. But the reason we don't choose huge numbers, the reason we keep our numbers small, is because we know that we're graphing these values. Why would I plug in a negative 53? You know, because then I've got to multiply that by 2, and then I have to graph. Okay, so I'm not going to choose huge numbers. I'd like you guys to all choose the same numbers. Okay, when a whole number, do you see this 2 right here? Does everybody agree that's a whole number? Right? When a whole number is connected to x, I want you to use this set of numbers, -1, 0, and 2. And it's already written in your table. Do you guys see that column? Okay. The reason why is it's much easier to grade, okay, if everybody's using the same input values. And then also when we're working together, okay, if you guys are using different numbers, it's kind of hard to help each other. All right, so we're just kind of all staying on the same page. But is this the only numbers I could have chosen? I literally could have chosen any numbers I wanted. Now that I have decided on my x values, I'm going to take these values and I'm going to plug them in to my function. This is a function. How do I know it's a function? Because y is solved for mx plus b. This equation is in function form. You with me? Okay? So I'm going to take -1 and I'm going to plug it in. Remember, guys, this is the only time we're going to do this. But I need you to see what we're doing. We're taking our x values and we're plugging it into the function. Our goal is to keep these numbers as simple as possible so that it's not difficult math. What's 2 times -1? -2. What's -2 plus 1? -1. Now, okay, you've got to understand this, okay? I took an x value. Look up here for a sec. I took an x value. I plugged it into the function, and something came out. That was the y value. What value came out once I plugged it in? What value? -1. So I'm going to pair together the x and the y value to make my ordered pair. -1, -1. Okay? All right, so now let's go down to the next x value. You actually did this in 7th grade math, okay?
I ain't get that though.
Nick, what's your question, bud?
What are we doing? I don't get it.
Look, do you see how you had an x value?
Yes.
Do you see how you plugged that into your function? The answer, when you plugged it in, the answer was -1. That's your y value.
Okay.
You match together your x value and your y value to make your ordered pair. Okay, so let's do it again. Let's plug in 0 for x. 0 is a real nice one to have in our tables, right? What's 2 times 0? 0. What's 0 plus 1? So what's my ordered pair now?
1. 0, 1.
0 got plugged in. 1 came out for my y. All right, go ahead and do your last one. Go ahead and do your last substitution. I will not require you to show your substitution on your homework. Okay?
I can do the next one.
All right. All right, so Michael, you want to give me the next one? Y equals 2 times what?
2 times 2 parentheses plus 1.
Yep, very good. And what did you get?
5.
He got 5. Is that true? 2 times 2 is
Yes.
4 plus 1 is
5.
5. Okay, so now I've got 2, 5. I want you to plot these 3 points on the graph below in your notes. Okay? Plot these 3 points now on the graph below. And what we're going to see, if we actually did this correct, if we made our substitutions correctly, it's going to form a straight line when I draw the line through these 3 points. Okay? All right, so this is what I'm going to require on your homework, okay? We just made a table and I showed you the expanded way so you could see how the numbers substitute.
It's supposed to be a triangle.
No, it's supposed to be a straight line. This is what I'm going to ask you to show. Are you paying attention? You might need to go back and watch this for your homework if you missed this. This is the type of XY table that I'm going to ask you to show. What is the X value and what Y value came out? Okay, remind me again, what X values did I use? Negative 1, 0, and 2. And what Y value came out when I plugged in negative 1? Negative 1. What about 0? 1. And what about 2? 5. And these formed my ordered pairs. This is what I'm going to ask you to show on numbers 10, 12, and 16. Okay? Those are your 3 graphs tonight. All right, so now... Okay, wait till I call on you. Now let's plot the points. Negative 1, down 1. Did you plot a point right here? 0, up 1. Did you plot a point right here? And 2, up 5. Did you plot a point right here? So now I need you to draw a straight line all the way through. No, that's not good. Draw a straight line through these points. Okay? As straight as you can. All right? Okay, so now I have graphed the linear equation. I want you to write the linear equation on your graph. Y equals 2x plus 1. All right, so here's the whole point of the lesson, guys. All right, this is important. Okay? What I'm showing here by this line on the graph, I'm not just showing 3 solutions. Look back to your terms. I'm showing all of the solutions. Wait a second, how am I showing all the solutions? What here about my graph would make it look like I actually have more than one solution? There's something that I did here on this line. Anybody see anything significant?
Arrows.
The arrows. The arrows actually show that my solutions can keep going. And the line, guys, this is the whole lesson right here. That line, how I drew that line actually highlights every single solution to this equation. I'm going to show you. Let's find an XY value where the line intersects it perfectly. So this one right here. Let's do this one. Do you see how right here on this point the line passed through perfectly? What is the ordered pair that represents this point? What's the ordered pair? It's 1, 3, right? It's 1, 3. Where 1 is which value, X or Y? So plug it in for X. What's 2 times 1? 2. What's 2 plus 1? And guess what? 3 is your Y. 2 plus 1 is 3. So here's what I'm saying. This ordered pair was not a part of my table. It wasn't there in my table. Yet, I can see the line passes through it. And when I plug in 1 for X, 2 times 1 is 2, plus 1 is 3, Y equals 3 also. That makes it true. Let's find another one just to prove our point. Let's come down here. Do you see how negative 2, negative 3, it passes straight through it? Negative 2, negative 3. You see that, guys? So what happens when you plug in negative 2 up here? What's negative 2? What's 2 times negative 2? Negative 4. What's negative 4 plus 1? Negative 3. And that's my Y values, negative 3. Do you see that? So here's what it shows. I need to be able to ask you this question and you need to know the answer. This is coming on your quiz. What does the line on the graph show you? Here's the answer. All possible solutions. You should write that down. The line on the graph, this is not in your notes, but it's important. The line on the graph shows me all possible solutions, not just the ones from my table. Because if you rewatch that part of the video, it might make more sense if you're confused, okay? The line on the graph shows me all the possible solutions, not just the 3 that I plotted. Is that making any sense, Connor? Any sense? A little bit of sense? Okay. All right. I just needed to make a little bit of sense. You don't have to have it perfect yet. All right, we're going to go on to example 2. I know I've got one more on there, but we're starting to run low on time. In example 2, this equation looks a lot different, doesn't it? Where's the rest of it? Right? Okay. Here's what I want you to see when you see an equation like this. I want you to be excited because there is actually no work to do. None. There's no work to do. Isn't that a great thing? You don't have to set up a table. And can I let you in on something? This is one of your homework questions. You won't have to show any work. All you will have to do is graph this if you know what to do. I'm about to show you. Do you see how it says y equals -3? All you have to do is plot a point on a y value of -3. That's it. But now, which way does the line go if the directions weren't giving it away? The y-axis goes which way? Up and down. So if you plot on the y, the line goes in the opposite direction. So it's a horizontal line. This will be very significant tomorrow. This will mean something tomorrow when we learn 4.2. Okay? So if you plot a point on the y, which way does your line go? Horizontal. Okay? So anybody want to take a guess for x? Do the next one. Just take a wild guess at it. Okay, for x. I'm going to raise your hand and tell me where you think that point might be plotted. Yeah, you're writing in pencil, so if you get it wrong, no big deal. Just erase it. Nick?
Alright, I'm a little stupid, but alright, so plot the point where the 2 at, and then...
On the x, right?
Yes, ma'am.
So based on what I said for y, which way do you think your line's going to go?
Up and down.
Up and down. It's going to go in the opposite direction. So my x goes left to right, so my line is going to go in the opposite direction, up and down. And this is a vertical line. All right, which it kind of gave it away in the directions too. All right, but it won't on your homework. All it's going to say, listen, it's going to say graph the linear equation. Is this still a straight line?
Yes.
Is this still a straight line, guys? Yeah. So technically it's still a linear equation, it's just a vertical line. You with me? Okay. All right, so now, here's that thing that we did at the beginning of class. You cannot graph, all right? So if there was also, okay, now again, the line shows us all possible solutions. That's important. This is the next most important, if not equally as important. You cannot, listen, this might be helpful for you to write down. You cannot graph an equation until it is in function form. Y is solved for. If you look back to the ones that we've graphed, y was always by itself. Are you listening? You might want to write this down in your notes. You cannot graph an equation until it's in function form. You can't graph it. So I'm going to start asking you these questions. Is this equation ready to graph? Is this equation ready to graph? Is it in function form? Is it in... What was function form again? Can anybody tell me? Y equals mx plus b. Is this equation solved for y? No, it's not. This one right here, it says y minus 5x. Y is not by itself. It is not ready to graph yet. I want you to solve for y. Get this in function form. Solve for y. Oh, sorry. Yeah, the notes got printed in the wrong order. Flip to the third page. The back side of the third page. Those pages got flipped on accident. I apologize for that. Okay? So turn to the third page in your notes and flip to the back and you'll see these review questions. Nick, how do I get y by itself?
Alright, so you do plus 5, 6. And then
Not 5, 6, but 5.
X.
X.
And then you cross it out.
Yep.
And it equals plus 5, 6 to that side too.
Okay, hold on. Time out. Okay. Now, Connor, Starling, can I add 5 plus 5x together to make 10x? Could I add those two together? No, I can't. So when I bring it down, y equals, which term would I write first? No, it's 5 plus 5x. There's no negatives. Which one would I bring down first? You said I can't add them together. All right, Connor, you want to try again? Okay, which term would I write first?
5x.
Yeah, very good. 5x plus 5. Okay, and now, mission accomplished, function form. Y is by itself. mx, which again, the 5 is your m, which we'll learn tomorrow, plus b, which is your number by itself. This is in function form now. Okay? All right, now let's look at this next one. The next one looks weird. Why? Why does it look different, guys? There's a fraction connected to y, but I'm not going to worry about that first. Because remember, my rule says to move what's not connected to y first. I want you to move that 4x to the other side and rewrite your equation. Go ahead and do that. Move your 4x to the other side and rewrite your equation, please. How do I move 4x to the other side? Subtract it, guys. Subtract 4x. Kelsey, can I do 3 minus 4x? Can I subtract those? No, I can't. Bring down the negative 1/3 y. All right, and Deasia, which term would I write first, the 3 or the negative 4x? Very good. Negative 4x plus 3. But now I have a fraction connected to my y. Does anybody know or remember, how can I get a fraction to completely cancel out to a 1? Does anybody remember, Josh? Yep, by what? Yep.
By the opposite.
Yes, very good. Okay, you guys did really well on that. What's the reciprocal of negative 1/3? Negative 3 over 1. Okay, so now my rule still applies, guys. I need to multiply. If I multiply this by negative 3 over 1 to get it to cancel, guess what I'm going to do to the other two terms? Multiply it by negative 3. Multiply each term by negative 3 over 1 or just negative 3. It's the same thing. Okay, so now I get y equals, what's negative 3 times negative 4x? Can someone raise their hand? What's negative 3 times negative 4x? Yes, I can. I can multiply them. Nick?
12.
12x. Very good. 12x. I can multiply my numbers, keep my x. What's 3 times negative 3, guys? What?
No, negative 9. No.
Is it negative 9 or positive? It is negative. Very good. Okay, is this in function form? Is this in function form? Y equals mx plus b. It's in function form. Okay? So on the last example, all right, we're running out of time. I'm going to change number 25. Listen carefully. On number 25 on your homework, I only need you to write it in function form. And come up with your table. I do not need you to graph it. Okay? So come up with your table. I'm even going to make it more basic. Your table of x values, and we'll keep it there. So we're going to practice one more. I need you to write this equation in function form. We've just done 2 together. Write this equation in function form. Remember what I said. You cannot graph an equation unless it's in function form. This is not. This equation is not ready to graph. Please go ahead and write it in function form. Solve for y. All right, so Mason's making a really good connection there. He's saying, you mean solve for y. That's exactly what I mean. And he's making the connection. That means function form. All right, someone raise your hand. What do you do first? Get it in function form. What do you do first to get it in function form, Mason?
Subtract 5x.
Yes, sir. I feel like you're doing better on these. You think you're doing better?
Yeah.
I think so. Because at the beginning you said unfortunately or sadly or whatever, right? I think you're doing better. All right, 2y equals, Cam, can I subtract these? 4 minus 5x? So which one would I write first?
Negative 5.
Very good. Negative 5x plus 4. Did you guys get that far?
Yeah. I do.
Okay, did y'all get that far? Michael, what would be my last step? I need to do one more thing.
You said what?
What's my last step to solve for y?
Divided.
Yep, divide it by what?
2.
Divide everything by 2. Now, just like Micah just asked, is this going to be a whole number when I divide it?
No.
You must leave it improper. Again, I will explain why tomorrow. Do not change that to a decimal. Don't say 2.5.
I got it right.
Okay? We need a rise over run for slope. Okay? All right, again, listen, for your homework at number 25, I only need you to get it in function form. Okay? The other three, hold on. I have not dismissed you. I know the bell rang. You have a 10-minute break. Flip to the back of your 4.1 homework. You're going to see that I have given you graphs. Okay, so 4.1 homework assignment. Let me see your paper, Josh. Okay, on your 4.1 homework, when you flip, you see this is the homework assignment. This is where you're going to do your work. This is where you're going to set up your table. On the back side of this paper, I have given you some extra graphs to graph numbers 10, 12, and 16. You need to number each graph, 10, 12, and 16. You need to number each one. All right, does that make sense? Do you understand? All right, 7 questions for homework. Remember number 25. You only need to get the equation in function form. All right, and that's it.